Hello, advanced physics students. This is Dr. Brenzy here. So, I'm guessing you're on this, watching this video because you're struggling with lesson 1.2.5 homework, and with good reason. It's because we didn't get an opportunity to actually talk about some really important formulas during class. But I want you to be able to make some progress on this homework, so I thought I'd make this video and present it to you so you can work out the problems on the homework assignment. So, in order to be able to do those homework assignment problems, we need to actually work with some formulas. We know that when you have constant acceleration, you have an acceleration graph, and it is constant over time. And so that's acceleration. And we also know that velocity is going to have some sort of slope to it. So we would say that the acceleration is equal to a constant, some number. The velocity over time is given by the velocity that we started off at, v initial, okay, plus at, where a is the acceleration, that constant, and t is the time. And then we come up here, we have displacement, and we found out that the displacement actually makes a parabola. It might be something like this. Right, and the formula for displacement is going to be E displacement as a function of time equals some initial displacement where it started. Okay, so on this graph, this starts at initial displacement of dI over here, plus an initial velocity times time, and we have to add an acceleration term to it, so we have 1/2 at squared. And sometimes I write it as a sub I because it's the initial velocity. So we're going to use these two formulas to predict, find velocity, displacement, and time of objects that are under constant acceleration. And usually the best example of objects under constant acceleration are those things that are under gravity. So things that, like Jim throwing or dropping a ball from a height of 2 meters. Gravity is a constant acceleration. I proved that to you by using the book today. So let's actually use what we understand about gravity, or about constant acceleration, to work through a problem similar to this. The initial displacement is given to us in the problem because it says he drops a ball from a height of 2 meters. So this initial displacement will be 2. Oops. I just noticed that my formula popped in here, so I'm going to finish that formula right there and then go back, and let's go ahead and start filling in these constants. So it starts off at an initial height of 2 meters. That's my initial displacement. My initial velocity is 0 meters per second. I forgot to put meters on that one. Because Jim is dropping the ball, he is not throwing it up and he's not throwing it down. So that velocity is equal to 0. And then the acceleration is the same as the acceleration due to gravity. Very often you'll see this written as small g, and that small g is equal to negative 9.8 meters per second squared. Okay. So those are the three constants we want to use in the displacement formula up here. Well, let's go ahead and use those. So let's ask ourselves, first of all, how long will the ball remain in the air? So Jim has, oops, need to back that up. So how long will the ball remain in the air? So we know that it starts off with an initial velocity 0 at 2 meters above the ground, and it will make a parabola. We know that already because displacement under constant acceleration makes a parabola. How long will this remain in the air? In other words, I want to know how much time has elapsed, this delta t right here. Actually, we can just call it time because our initial time is 0. So let me erase that and just call it time instead of delta time. So we want to figure out that time right there. All right, so let's start off with our formula. And let's plug in the constants that we know from the problem. Our initial displacement is 2 meters. Our initial velocity is 0. And our acceleration due to gravity is negative 9.8 meters per second squared. So that's equal to 2. Now anything times 0 is just 0, so I can set that equal to 0 and not worry about it. Let me bring this down just a little bit. 2 plus 1/2 times negative 9.8, that's equal to negative 4.9, times t squared. Okay. So that is the formula for displacement as a function of time. And if I were to graph displacement versus time, I would get this parabola. So let's go ahead and ask ourselves, okay, when this ball has finished falling, what is its displacement going to be? Well, its displacement is going to be 0, right? Because this along here is a displacement of 0. So when the ball hits the ground, we know that we can set that displacement equal to 0. Our initial displacement is 2 plus negative 4.9 times t squared. And this is a quadratic equation that I can solve for t. So let's go ahead and do that. I almost said t squared, but it's actually t. So we're going to subtract 2 from both sides. We're trying to isolate t by itself. So we have negative 2 equals negative 4.9 t squared. And coming up here, whoop, whoop, whoop. Oh. Oops. Trying to pick a color here, and I'm having a hard time doing it. And now we divide both sides by negative 4.9, so I have negative 2 divided by negative 4.9 equals t squared. Well, that's about 0.6. And that means that our t is equal to positive or negative 2.45 seconds. Okay, now in algebra, you know that when you have a quadratic equation, you're going to have 2 solutions. We have 2 solutions here, but in physics, one of these solutions makes absolutely no sense to us. And the negative time is the one that doesn't make sense to us because it doesn't really make sense for the ball to actually hit the ground before Jim drops it. So we need to take the positive value. And so the time that it takes for the ball to remain in the air is 2.45 seconds. Good. Now that you've gone through that example, I'm going to let you try an example on your own here. All right, so Terry drops a ball from a building of 20 meters high. I'm going to first ask you, what are the values of the acceleration, the initial velocity, and the displacement? The initial displacement, excuse me. And then I'm going to have you calculate when the ball will hit the ground. And I'm going to ask you what is the speed when it hits the ground, but I need to give you some more information first. So go ahead and figure out just A and B here. And when we come back together, I'll give you the answers I came up with, and we'll see if we agree. All right, welcome back. So our acceleration is, oops, that thing popped on again. Our acceleration is the acceleration due to gravity, so my initial acceleration, oops, oh, excuse me, I'm tired, is equal to negative 9.8 meters per second squared. My initial velocity is equal to 0 meters per second because Terry is just dropping this from the height of a building. My initial displacement is equal to 20 meters. All right, so when will the ball hit the ground? Well, the ball hit the ground when when the distance as a function of time is equal to 0. And so that will turn out to be 20 plus 0t plus 1/2 times negative 9.8 t squared. And if I remember my practice correctly from earlier today, I know that that happens at a time of 2 seconds. So once you solve this quadratic equation, the solution is going to be t equals 2 seconds. Okay, so let's take that information to help us answer part C. What is its speed when it hits the ground? Now I need to introduce you to another formula here. Oops, didn't mean to do that, sorry. I need to introduce you to another formula that you can use to describe the velocity as a function of time. Well, that happens to equal the initial velocity plus the acceleration times time. So the initial velocity was 0. Of course, acceleration is negative 9.8. And the time that it hit the ground is 2 seconds, so I'm going to go ahead and plug 2 in for there. And when I evaluate that side, I get v of 2 equals negative 18 point, excuse me, negative 19.6, I'm sorry. Negative 19.6 meters per second. Okay. So that's how fast it will be going if or when it hits the ground. Oh, excuse me. All right. I'm going to actually skip these right here. And we're going to go to Dr. Brenzy here, launching a ball in the air. All right. Actually, I'm going to go ahead and pass on this one. I think the video is long enough, and I hopefully have given you those two formulas that you need to really help you succeed on the homework. And let me find a blank space to just remind you of what those two formulas are. Make sure you write these down if you are not very good with memorizing formulas. But the displacement as a function of time equals the initial displacement plus the initial velocity times time plus 1/2 times the acceleration times time squared. And then you have a formula for velocity as a function of time that equals to the initial velocity plus the acceleration due to gravity or the acceleration due to anything really, times time. So those are the two big formulas you're going to need to use to work on the homework. And I wish you the best of luck. Feel free to send me an email, or you can call me at 720-443-5505 if you have any questions. All right, take care and have a good weekend. Bye.